Hello friends and good afternoon. Today we shall solve a numerical on slope deflection method. I have drawn a continuous beam here, beam ABC. AB part is subjected to 20 kN point load and BC is subjected to an eccentric point load of 40 kN. So distances are like this. There is some more data given. There are two things. One, flexural rigidity of the beam is given as EI, which is equal to 3900 kN meter square, and sinking of support B is given. It means it will go down by 30 mm. So whenever it is going to go down, whenever there is sinking of support, we will have to take into account the fixed end moments because of sinking. Okay, so those moments will be like this. So here is additional minus 6 EI delta upon L square. Here is also minus 6 EI delta upon L square. And for beam BC, there will be clockwise fixed end moment because of sinking. Why? For span AB, B is down with respect to level of A. So it is going down, delta is minus, and for beam BC, C is up with respect to B, so there is plus delta value and not minus. So one will be minus, another will be plus. This we will have to take into account. Now, whenever we are solving slope deflection method problem, our very first step is always kinematic indeterminacy, Ki. So how to determine Ki? First thing, identify the number of joints, correct? So how many number of joints are there? 3, A, B and C. Then degree of freedom without support is 3 per joint, so 3J, 3 into 3 is 9. After that, you find out how many number of reactions are there. Number of reactions, because number of reactions are going to prevent these degrees of freedom. So end A is fixed, so there are 3. B is roller support, so 1. C is again 1 roller support, so 1 more. So 1 plus 1, 2, 2 plus 3, 5. Then, how many number of members are there? Number of members. They are AB and BC, 2. So our Ki value or degree of freedom is equal to 9 minus 5 minus 2. So this is 2. Okay. So which are the two joints, or which are the two degrees of freedom that are going to take place in this beam? One is rotation of B and another is rotation of C. So our aim will be to find out these two rotations and then solve beam ABC. Okay, so this is our first step. Our second step is finding out fixed end moments. Fixed end moments. Okay. So what are fixed end moments? We should know what are the standard equations for standard loading. A, B, C, B is an internal support, so we are going to assume B as a fixed support. So for beam AB, we will have two fixed end moments. One is MF AB this beam AB is subjected to complete UDL. So minus WL square by 12 is the standard equation for finding out fixed end moment. So minus 20 into 6 square upon 12. Okay, so this is how much? 6 square is 36 upon 12. So it is 3 into 20 is minus 60. So it is minus 60 kilonewton meter. Then MFBA, it is plus WL square by 12. So it is plus 20 into 6 square by 12. So finally the answer is plus 60 kilonewton meter. Then MFBC, BC span is subjected to eccentric point load. So minus WAB square upon L square. So minus 40 into A is 2 meter, B is 3 meter divided by 5 square. So calculate this value. So that comes to be, let us see, minus 40 into 2 into 3 square upon 5 square, minus 28.8. Okay. Then MFCB. What is MFCB? Plus WA square B upon L square. So it is plus 40 into 2 square into 3 upon 5 square. So 40 into 2 square into 3 upon 5 square. It is plus 19.2 kilonewton meter. Okay. Let us go to next step. Step number 3. I will rub this now. Step 3 is slope deflection equations. Slope deflection equations. We already know these equations from the derivation of slope deflection. So for span AB, our equation will be 2EI by L into bracket 2 theta A plus theta B minus 3 delta by L. See, for span AB it will be minus 3 delta by L because B is going down. Minus MF AB. Let us substitute all these values. 2 into EI is given as 3900. Keep it as it is because it is in appropriate units. We want units in kilonewton and meter. L is 6 into bracket theta A. Theta A is 0 because end A is fixed. So there is no rotation of A. So theta A is 0. Theta B is unknown. We have to find. Minus 3 into delta is 30 divided by L. L is 6. 30 is in millimeter. Convert this in meter. So 30 divided by 1000. MFAB minus 60. Keep it as it is. Do not make minus minus plus. So let us solve this. So this is 2 into 3900 upon 6. So it is 1300 theta B minus again 2 into 3900 into 3 into 30 upon 6 into 6 into 1000. Okay, and minus 60. So this is minus 40.5. Actually this is minus 79.5, minus 79.5. Now MBA. What is MBA? 2EI by L into bracket theta A plus 2 theta B minus 3 delta by L plus MFBA. So again substitute the values. 2 into 3900 upon 6 into bracket, again theta is 0, so this is 2 times theta B minus 3 times 30 upon 6000, I will write directly now, and plus 60. Let us simplify this first. So MBA, we are going to get this as 2600 theta B so this is minus 19.5 plus 60, so this is 40.5, so plus 40.5. This is MBA. Similarly, find out MBC. Write the equation first. 2EI by L into bracket 2 theta B plus theta C. Now here is plus 3 delta by L. Why? Because of this. And minus MFBC. So 2 into 3900 upon span for BC is 5 meter, then 2 theta B unknown plus theta C, this is also unknown, plus 3 into 30 upon 5000 minus MFBC. How much was minus MFBC? I think it was 28.8. So simplify this. 2 into 3900 into 2 by 5, so this is 3120 theta B plus 2 into 3900 upon 5 is 1560, so it is 1560 theta C plus 2 into 3900 into 90, 3 into 30 90 upon 5 into 5000, so it is 28.08 minus 28.8, so it is minus 0.72. This value is minus 0.72. Next, MCB. What is MCB? 2EI by L into bracket theta B plus 2 theta C, again here is plus 3 delta by L, and MFCB. So 2 into 3900 upon 5 into theta B plus 2 theta C plus 3 into 30 upon 5000 upon plus 19.2. Correct? I will write MCB here. MCB is equal to 1560 theta B plus, that is double, so 3120 theta C, and last term 2 into 3900 into 90 upon 5 times 5000, 28.08 plus 19.2, it is 47.28. So this is MCB. Okay. Now there are next steps. So step 4 will be equilibrium equations. What are these equilibrium equations? As per the compatibility condition. So one condition will be at joint B. What will be this joint B condition? MBA plus MBC, it is equal to 0. So we have got all these values. So BA equation is here, BC is here, correct? So 2600 theta B plus 3120 theta B. Let us see how much is that. 5720 theta B. Please verify. Yes. Plus 1560 theta C. (40.5 minus 0.72). 40.5 minus 0.72 is 39.78. So it is plus 39.78. I will take it on right hand side. It will become minus 39.78. So this is equation 1. Second condition will be at joint C. And that condition is MCB is equal to 0. So what is MCB? MCB is here. 1560 theta B plus 3120 theta C, it is equal to minus 47.28. So solve equations 1 and 2. We get theta B and theta C. Okay, so what is theta B? Just let me check. So it is minus 0.0033 theta B value, and theta C is minus 0.014. So now our next step will be final moments. So MAB, what is MAB? 1300 theta B minus 79.5. So 1300 into what is theta B? Minus 0.0033 minus 79.5. Simplify this. Minus 83.79. I'll show it here. 83.79 kilonewton meter. Then MBA. What is MBA? 2600 theta B. So it is 2600 into minus 0.0033 plus 40.5. So it is minus 2600 into 0.0033 plus 40.5, 31.92. Calculated answer is plus, so that is a clockwise movement. So I'll show it here. So this has to be anti-clockwise, because in step 4 we are saying MBA plus MBC 0. So if MBA is plus, MBC has to be minus. So this is 31.92 kilonewton meter. MCB is 0 because we are written itself this condition in step number 4, equilibrium equations. MCB is 0. So we have got all the equations now, or values also. Now we have to draw shear force diagram and bending moment diagram. So I will draw all this now because we don't need this anymore. Now I will do all the calculations here on right hand side, so that below this we can draw SMD as well as BMD. Okay, so our next step is reactions. So this is A, this is B. Here are the two moments which are final moments. 83 point, I'll show here, 83.79 kilonewton meter. This is 31.92 kilonewton meter. Here is the UDL, 20 kilonewton per meter. Okay, we have to find these reactions first, RA and then RB1. So summation of moment about A is equal to 0. Span is 6 meter. So write down moments because of all the loadings. RB1 into 6, anti-clockwise movement about A, so minus RB1 into 6. Then this is clockwise movement plus 31.92. Then because of 20 kilonewton per meter, there is a clockwise movement, WL square by 2, because it is UDL. So 20 into 6 square by 2. And final moment on A is minus 83.79. It is equal to 0. Okay. So from this we will find out how much is RB1. Let us calculate. So 31.92 plus 20 by 2 is 10 into 6 square minus 83.79 upon 6. So it is 51.36. So I'll write directly RA value here. Let us write in red color so that it is easy to identify. So it is 51.34 kilonewton meter. Kilonewton. Now summation Fy is equal to 0. You apply this condition to this beam, you will get RA plus RB1, which is I will directly write as 50. This is not RA, I'm sorry. RB1 is 51.34, correct? It is equal to 20 into 6, 120. So RA from this will be 120 minus 51.34, 68.66. So RA is 68.66, not 51.34. So let us write here 68.66. We will not write RB1 here because there will be another RB from beam BC. So let us first of all find that value. Okay. So let us again draw beam BC. Show the moments and external loading. 31.92. Now here on B it is anti-clockwise. Then there is 40 kilonewton point load. This distance is 2, this is 3. We will again find the two reactions using same conditions. Summation of moment about B is equal to 0. Here I will show RC and this will be RB2 I shall say, because RB1 is here. So net RB value will be algebraic addition of RB1 and RB2. If plus, add them. If negative, subtract both. If 1 plus 1 minus, take as it is and then take the net value and write here. So let us first of all find RB2. So summation of moment about B is equal to 0. From this we are going to get again minus RC into 5. Okay. There is no moment here like here. Then moment due to 40 is plus 40 into 2 and this minus 31.92. It is equal to 0. Let us calculate RC first. So it is 40 into 2 minus 31.92 upon 5. So it is 9.62. RC is 9.62. I can write directly here. 9.62 kilonewton. Now RB is remaining. So first of all find what is RB2. What will be RB2? 40 minus 9.62. Because if you apply this condition again, summation Fy is equal to 0. What are we going to get is RB2 plus this RC is 9.62. It is equal to 40. So what will be RB2? 40 minus 9.62. So it is 30.38. Okay. So what will be net RB? Calculated answer of RB2 is plus. It means assumed direction of RB2 which was upward is correct. Same goes for RB1. Calculated answer of RB1 is also plus. It was 51.34. So add both the values of RB and write them here. So how much is that? RB1 is 51.34 plus RB2 is 30.38. So it is 81.72. Okay, 81.72. So now we can draw shear force diagram because we have got all the reactions. External loading also we will have to consider. So let us take first of all these projections and draw appropriate shear force diagram. So shear force on A is reaction on A, 68.66 approximately. I will draw now the ordinates. So this is 68.66. Shear force on left side of B. So 68.66 minus this loading on left side of B. 20 into 6, that is 120. So that will be minus 51.34. So 51.34 below the reference line. Let us say here. Okay. Since it is UDL, straight line going down. On just right hand side of the B, what is reaction? 30.38. So minus 51.34 plus 30.38. It is minus 20.96. Sorry, extremely sorry. Minus 51.34 plus 81.72. So that will be 30.38. 30.38. So this is value. It will be same up to 40 kilonewton point load. So from this 30.38, now you subtract 40, you will get minus 9.62. Then you continue up to C. This is your shear force diagram. Show appropriate symbols, signs, not symbols, plus and minus. Now wherever shear force is changing the sign, those will be the locations for maximum bending moment. Now we want location of maximum bending moment. So how to get this? Similarity of triangles. When we are assuming this as x distance, total is 6. So how much is this? 6 minus x. So when x is the distance measured from this point, we have a vertical ordinate 68.66. And when 6 minus x is the distance, we have vertical ordinate 51.34. Please see, we are doing this similarity of triangles between these two. Okay, so don't take this ordinate 30.38, no, 51.34. Now you take cross multiplication. So 51.34 into x is equal to 68.66 into 6 minus x. Let us do the calculations. 68.66 into 6, it is 411.96 minus 68.66 x. You bring this on right hand side, so you will get x as 411.96 divided by addition of these two, 51.34 plus 68.66, so it is 3.43 meter. 3.43 meter. So we have identified location of zero shear force where we are going to get maximum bending moment. So now you take a section at x is equal to 3.43 meter in the loading diagram. So here is the section. So let us write first of all equation for bending moment at x is equal to 3.43 meter. What will be equation? 68.66 into 3.43 next minus 83.79 next moment due to 20, so minus 20 because this is anti-clockwise, both these are anti-clockwise, hence minus, so minus 20 into 3.43 square by 2. Let us calculate. 68.66 into 3.43 minus 83.79 minus 20 by 2 is 10 into 3.43 square. So it is 34.06. So this answer is minus, plus, calculated answer is plus. It has to be plus because it is maximum. Then similarly you get what is moment here. We shall say this point as D. So bending moment at D is equal to 9.62 into 3. Now I have taken section here. So this is right hand side of the section. Moment is anti-clockwise. as per the sign conventions, anti-clockwise moment on right hand side of the section will be treated positive. So this answer is positive. Do not write this minus because it is anti-clockwise. It is on right hand side of the section, hence it is positive. So 9.62 into 3, how much? 28.86 kilonewton meter. Okay, so all moment values we have got. Let us plot the BMD. Simple. If values are minus, plot them below the reference line. If values are plus, plot them above this black line. Simple. So moment on A, 83.79, it is anti-clockwise, so minus, we will plot it below the reference line. 83.79 kilonewton meter. Then moment on zero shear force is how much? 34.06. So it will be somewhere here. 34.06. Then moment on B, 31.92. Plot it here. Why have I plotted it below? This is the section line. On right hand side of the section line, moment is clockwise. So again, as per the sign convention, if movement is clockwise on right hand side of the section, that will be minus. Hence it is below the reference line. Movement on D, here it has to be positive because shear force is again changing the sign, just like here, plus to minus. So on this location, moment will be maximum, which will be positive. Value is 28.86. 28.86 kilonewton meter. What about moment on C? MCB, we have already seen that at 0. Over. You just have to now join the ordinates of the bending moment diagram. From A to B there is UDL. So from here to here, variation will be parabolic. Something like this. From B to C there is only point load. So variation is linear. Straight line. Over. This is minus. This is plus. This is minus. This is plus. So this is your BMD in black color, and in red color we have our SFD. Yes, this is time consuming. This whole procedure is time consuming, but there is no alternative, and this is known as BMD on tension side, and you are expected to draw BMD on tension side only. Do not make a practice of drawing BMD by overlapping. Some just draw BMD of fixed end moments. Over that fixed end moments, they overlap bending moment diagram because of external load. Do not make this practice, because that is not going to get any concepts clear in the next subjects like structural design. Okay, so BMD on tension side is important, lengthy, but this is correct way for the approach. Let me know what you have understood from this and whether you have liked the video or not.